Hello, and welcome to Mass Calculations. This is the fifth video in the Scale Factor Stoichiometry series, and I'm particularly excited about this video because everything's kind of been building to this. These are the actual types of problems that chemists are confronted with, and everything up till now has been kind of preparation for it, if you will. You know, if you could imagine that you're an athlete and you need to run the 100-meter dash, and we've been teaching you how to tie your shoes and get in starting blocks and things like that. But this is the actual event. This is the actual what we are here to do. So let's go ahead and get this show on the road. In order to be successful, you need to know how to create a standard mass balanced equation, and you should know how to use a situation value to create a scale factor, and then use the scale factor to rescale a mass balanced equation. These have been covered in the previous 4 videos. So if you're unfamiliar with how to do these things or what these things mean, please go watch the previous videos. But if you are ready to dive on in, then in this video, you will learn how to take a situation value for one chemical in a reaction and then use that to determine situation mass values for specific reactants or products. Back to our cookies. So here is our cookie recipe. Again, a mass-based cookie recipe. And we're going to kind of conceptually think our way through the following situations. So if you have 100 grams of sugar in your house, how many grams of flour should you use? So I'm just connecting one ingredient, sugar, to one other ingredient, flour. Well, I can see that 100 grams is half of the sugar, and so I would want to use half of this. That's 225. What if I have 20 grams of sugar? Okay, well, that's 1/10. I'm making a 1/10 batch here. So that would call for 45 grams of flour. What about 1.35 grams of sugar? Okay, this one I'm not going to be able to just kind of think my way through this one. So let's go ahead and take a look at the scale factor method. Situation amount over standard. Remember, you prefer to sit over stand. The situation, 1.35 grams of sugar. The standard, 200 grams of sugar. Grams of sugar will cancel, top and bottom. And that's our scale factor, a dimensionless number, which we can multiply by the amount of flour. So that tells us that we will need 3.0375 grams of flour. I could apply this to the whole recipe, and if I was actually making cookies, I would need to. But the question only asked me about the flour, so I'm not going to do every other ingredient. I'm just going to do the flour and move on. So let's go ahead and actually look at a chemistry problem. But before we do, remember you will often have one chemical that determines the scale of your reaction. Mass calculations typically ask you to determine one and sometimes more rescaled value, but it's very common for them to only ask you about one. And it's just like rescaling equations, but shorter because we only have to apply the scale factor to the chemical of interest, and we don't have to redo the whole equation, though some of you may want to, and we'll talk about that. So here we go. Here is a full-blown chemistry mass stoichiometry problem. If you wish to make 2 grams of silver by reacting copper-silver nitrate, how many grams of copper will be consumed? So there's our mole balanced equation handed to you for free. Let's go ahead and take a look at our standard mass balanced equation. There it is. If you don't know where this came from, please go view our earlier videos. You need to understand how we went from this equation to this one. Assuming you do get this, it's time to look at our situation quantity, 2 grams of silver. Standard quantity is 215.8 grams of silver. Scale factor comes from situation over standard. Grams of silver cancel, top and bottom. And then when I look at what the question asked me, it says how many grams of copper will be consumed. So I'm just going to apply the scale factor to the copper, and I'm done. This is different from what we've done before, because all I did was apply the scale factor to the copper, because that's all the question asked me about. So that saved me a little bit of time. 0.589 grams of copper is what will be consumed. Let's look at another problem. What mass of lead iodide will precipitate if 0.25 grams of lead nitrate is added to a solution with excess potassium iodide? And what mass of potassium iodide will react? Well, there's our mole balanced equation, and there's our mass balanced equation. Situation over standard is the scale factor. See if you can think to yourself before I reveal it. Situation value and standard value. Okay, there's the situation value. There's the standard quantity. and we get the scale factor by doing situation over standard. Grams of lead nitrate will cancel top and bottom, and then I will apply the, well, let's go back to the question. It says, what mass of lead to iodide will precipitate? All right, so I've been asked about the lead to iodide. So I'll apply the scale factor to that, and there we have our answer, 0.348 grams of lead iodide. Now, wait, there's more, right? What mass of Ki will react? Well, let's just take the scale factor and apply it to the Ki mass, and there we go, 0.251 grams of Ki. Now, if you really want to, you can just go ahead and keep rescaling equations. You can just put the scale factor in front and just distribute it on through, as we learned in previous video. And this is the entire rescaled equation. And then you can just pull the answers out of that. Like you could go back to the question and say, all right, well, it asked me about lead iodide. Okay, there's that. And then it asked me about potassium iodide. And then you have your answers. So if you really like the old method, if you just felt like you could do this better, go ahead, stick to it. All right, some practice problems for you guys. A chemist hydrolyzes 5 grams of water into its components. How many grams of hydrogen will be produced? And there's the equation for you. Okay, a driver's side airbag has 15 grams of sodium azide. If there's a crash and the airbag goes off, how many grams of sodium will be produced? There's the equation for you. Your chemistry teacher wants to sell 2.5 grams of silver on the black market. Ooh, what's going on? Has he been strapped with some hard financial times? Maybe the coronavirus has given him some unexpected bills. At any rate, he needs to know how many grams of silver nitrate to react, as well as how many grams of zinc he wants to put in. And here's a little present for you, the mass balanced equation. Look at that. So I just went straight to the mass balanced equation for you. Please pause the video at this time. These problems will take you a couple minutes to do. Take that couple minutes and see what you can do. Again, pause the video now, and then when you resume, the answers will be here for you. Welcome back to the video. I hope that you did in fact pause and that you took a couple moments to work out the answers, and I hope that your answers agree with the ones I'm about to put up. So here's the process for each of them. There is the mass balanced equation for water being hydrolyzed. There's the scale factor, and then apply to hydrogen. 55.6 grams of hydrogen will be produced. Mass balanced equation for sodium azide decomposition. Situation over standard. There's our scale factor, and then we apply it to sodium, and you get 7.84 grams of sodium out. And then for our last problem, there is the situation over standard. There's the scale factor, and then we're going to apply it to the silver nitrate, and then we're going to apply it to the zinc, and then that is how our chemistry teacher will get that silver that he is going to sell on the black market. All right, watch this video as many times as you need to get a feel for how to solve these problems, and I look forward to seeing you in the next video, where we will learn how to solve limiting reactant problems.